So hello everyone. First of all, thanks to organizers for such a good event. It's a great opportunity for all of us. I'm Yilmazcan. I'm the colleague of previously you've seen two beautiful ladies over there. So I'm a PhD student in computer science department at ETH Zurich. And today I will try to make a really swift presentation about our model, a deep generative model for clickstream analysis. So let me briefly introduce our problem first. The recent statistics show that more than 97% of online shopping users are just exiting the e-commerce websites with no purchase at all. And that's why some e-commerce websites are using machine learning models to detect when users are about to exit. And that helps them to trigger some potential marketing interventions. So at the end of the day, we have the research question of how can we detect the users who will exit with no purchase? For this, of course, there's some previous works over there. Previous works have modeled the sequence of the page clicks of online users in mainly two different ways. So the first approach is to use a variant of a recurrent neural network, like some LSTM models you can see over there, to capture the long-term dependence among the sequence of the page clicks. This leads to accurate results in terms of the prediction performance, but it doesn't have the ability to capture the latent shopping phases of the users, which is a nice thing to have for interpretability reasons. And on the other hand, the second approach is to use a variant of latent variable models, such as a hidden Markov model or any other variant of this. And with this way, this leads to suboptimal results in prediction performance in some cases, yet it has the ability to capture latent shopping phases of the users, such as if the user is going through goal-oriented phase, if the user is just browsing in the website, if the user is in flow, he lost the sense of time, or not in flow, etc. So in our work here, we propose an attentive deep Markov model, which we call Clickstream DMM in this context. And to the best of our knowledge, this is the first Clickstream model that jointly learns both principles from the previous literature. So it learns the long-term dynamics of the page clicks with its attention network, and also it learns the latent shopping phases of the users with its latent variable model. And the experiments shown that our model consistently outperforms the state-of-the-art algorithms by more than 11%. And we made our experiments based on more than 26,000 online sessions, which are all provided by Digitech Galaxus. For those who you don't know, this is one of the largest e-commerce platforms here in Switzerland. And before diving into our model components, let's have a look at what kind of inputs we have in terms of the data set. So our data set comprises a set of online sessions where each session is represented by both static and time series features. And static features encode some user level information such as the age, the gender, the type of the account. On the other hand, we have some time series features which encode the sequence of the page clicks and their associated timestamps showing exactly when this page click had happened. And since we have the timestamps, we further derive another feature we call time spent on a given page. And at the end of the day, we are performing a prediction task, so we have a binary label to indicate whether or not the purchase happened at the end of this session. So on the right side, hopefully you can see our model architecture, which mainly has 5 neural network components. You can see them as black boxes over there, because they're in fact a black box neural network component. So the first 3 neural network components generate the latent variable mechanism of our model. So typical to hidden Markov model, we have a transition network that specifies the transition probability among the latent variables of each time step. Further, we have 2 emission networks. So the first one is page emission network that gives us the probability of a certain page click given its latent variable. And similarly, we have a time emission network which gives us the probability of time spent on this given page once we know its latent variable. So with the calculation of the latent variables of all time steps, we feed them into our attention mechanism. And as an output, we get so-called aggregated representation over the entire session, which is denoted as Z tilde here. And as the final step of making the prediction, we are feeding this aggregated representation into our predictor network. In this practice, it's a multi-layer perceptron, but it could be any other black box model as well for generalizability. So let's briefly talk about some of our results. We have made our evaluations starting from 6 pages ahead to the exit, And we did it on purpose because even though in real data we know which page is the last page of the sequence, in the real time we may never know which page is the last page, right? So a user can still continue to click on next pages at any time, or he or she just may immediately leave the website. So here we want to measure the early warning performance of each model, and we need this for the real world deployment. So on the left side, you can see the numbers showing the average performance across all the time steps of evaluation. And based on this, you can see that basically our model achieves more than 11% of performance improvement in terms of area under the ROC curve. The similar performance improvement has been achieved in terms of area under the precision recall curve as well. On the right side with the plot showing the area under the ROC curve, with the solid blue line, you can see that our model consistently outperforms all the benchmark models across all time steps. But another thing to notice here is that among these benchmark models, the best performing variant is recurrent neural network when we have the full session information, in other words, the full sequence of the page clicks. But when we have less and less information, the best performing variant becomes a latent variable model. And this is aligned with our motivation that the both approach is needed and their combination is superior. So for the final words, I just wanted to quickly introduce here our theory-informed model, which covers the both principles from the previous literature. And our performance is particularly affected when we are making the prediction multiple pages ahead. And of course, our work is generalizable to other time series settings. So thank you so much for your attention. And if you want to know more about our work, you can check our paper in the ACM Web Conference next month. Thank you.
Thank you very much for that, Yilmazcan. We have time for a couple of questions. Yes.
Hello.
Hello.
Congrats for the paper on dab. I'm just wondering on the previous slide where you had the figure at the right, when it comes around 0, I see most of the methods converging.
Yes.
How do you explain this? Is it perhaps some...
No, it's actually like, sorry to interrupt, but it's really quite easy to explain. And this is sort of a flow from the previous works that have been built up, including ours actually. Most of the time when there's purchase, you can see the checkout page on the last page of the sequence. And many neural network models are easily converging to this finding checkout page in terms of an indicator of this purchase feature, basically.
Thank you.
So yeah, thank you so much for your question.
Thank you. Any other questions? Okay, great. Thank you very much.
Thank you.
Oh, sorry, I didn't see your hand there. Go ahead.
So, sorry, not used to the microphone. So the question is that I see that you use user data, but what about the people that go on the site on, let's say, private mode and they don't want to connect to the account? How do you identify this, if he is going to purchase something or not?
Well, I mean, I don't have the expertise on how basically Digitech manages such things. So it's a sort of private company situation. But from our side, we are not using any information about the previous sessions or previous logins from the same user, but only the current session. So if in the private mode, if they still store the history of the pages, given that private window, we can still do the prediction, but it's really company-specific question, and I don't know how the cookies have been managed in that sense, so I'm really not sure.
What about if no private window is just going on a simple browser but no connection, so they don't connect to their account?
But we are not, okay, now I see your question, okay.
No, I asked more, so it's good.
Well, if you don't have a user-specific information, you can just basically, for the practice, you can fill with mean values and still you can use the history of the page clicks, because this would be a typical practice in many machine learning models. But for the details of how can we further improve the performance, I don't know, we need to think about this. Thank you.
Thank you very much, Yilmazcan. Let's give him another applause.
Thank you.